Good morning, first years. We have discussed what is uniform circular motion. Already, uniform circular motion is over now. So this is belongs to motion in a plane. Motion in a plane. So motion in a plane chapter. In motion in a plane chapter, this is the last topic. What is the uniform circular motion? So already we have discussed about in uniform circular motion of angular acceleration. That is that is centripetal acceleration. So centripetal acceleration is equal to A is equal to V square divided by R. R we write simply AC is equal to V square by R. So this is the centripetal acceleration formula. Already we have discussed about centripetal acceleration. Okay, na? In uniform circular motion, this is a, for example, this is a circular path. So in this circular path, a body moving in uniform circular motion. So then body moves from P1 to P2. The body moves from P1 to P2. This is the angular displacement. Okay, no? This is the angular displacement, and this is the velocities, direction of velocity of the particle. Then we can find the angular acceleration. AC is equal to V square by R. So it is already over now. Now remaining topic, angular velocity. What is mean by angular velocity? So generally, what is mean by velocity? Velocity means displacement by time. Okay, here we go with angular velocity. Angular velocity means angular displacement by time. So angular velocity we write omega. Omega is called angular displacement, means we are writing d theta by dt, change in time. Total omega is equal to d theta by dt is the actual definition. So rate of change of angular displacement, it is nothing but rate of change of angular displacement. Rate of change of angular displacement. Rate of change of angular displacement is called, rate of change of angular displacement is called rate of change of angular displacement is called angular velocity. Okay, this is the common definition. We write omega. Okay, so now we go with the angular velocity. Okay, angular velocity. So we know that what is meant by angular velocity. This is a general definition of angular velocity. So angular velocity is equal to what now? Angular displacement by time, that is omega is equal to d theta by dt. Okay, so now we clearly what is the difference between angular velocity and linear velocity. Okay, first of all we consider what is the difference between linear and angular. We go with linear and angular now. I am writing here, this is linear or straight line, this is angular or circular path. This is linear means straight line. Angular means circular path. So I am going to discuss about difference between linear and angular. Okay, na? What is the difference? So how to write the physical quantities in linear displacement, in linear and angular. Okay, so first of all we write linear. linear motion. This is nothing but linear means linear motion, angular motion. This is nothing but a circular path means circular motion. So here in linear motion we write x. X is the displacement of the body. Here this is circular motion. That's why this is the circular motion. So that's why we are using theta. So theta is the, what is theta here? Theta is the angular displacement. So what is this? This is the displacement. Displacement. We use x. Here displacement we use theta. Here after displacement by time. So that is velocity. I am adding velocity. So velocity is equal to, what is the formula? Displacement by time. So here angular velocity. Angular velocity means angular displacement by time. So here v is equal to, we are writing dx by dt. So change in displacement by time. Here this is angular velocity. So the angular velocity is equal to, we are writing omega. Displacement theta, angular displacement, that is angular displacement. This is angular displacement. Angular displacement theta. Theta is the angular displacement. X is the linear displacement. Velocity v is the angular velocity. Omega is the, v is the linear velocity. Omega is the angular velocity. So angular displacement, that is in omega is equal to d theta by dt. V is equal to dx by dt is the, v is equal to, we are writing different terms from here. X, we are using x because this is linear. Here we are using theta because this is angular motion. Here this is, we are using v d theta by dt. And acceleration. Acceleration is equal to displacement by time. Acceleration is equal to velocity by time. So here also acceleration is equal to, we are using alpha. Alpha is equal to d omega by dt. D omega by dt. Or acceleration is equal to d by dt. Or what is v? V is equal to dx by dt. So that is d by dt into dx by dt. That is d square x by dt square. Here also alpha is equal to, we are writing d square theta by dt square. D square theta by dt square. So this is the main difference. This is the main difference between linear and angular motion. Okay. Here we are using theta. This is nothing but angular displacement theta. Here linear displacement x. Okay. So now we go with the relation between angular velocity and linear velocity. Okay. First of all, relation between angular displacement and angular displacement. Displacement and angular displacement. So that's why. So consider a body or object. Consider a body object in uniform circular motion. The body is in uniform circular motion. The body is in uniform circular motion. For example, at point P, so this is the uniform circular motion of a body. That point, body at point P1. So after some time, the body object at point P2. So what is the distance? And the body travels from P1 to P2. The angle is theta. Here the radius is r now. Radius, circular path radius is r. So here P1 to P2, the body moves. Body moves P1 to P2. P1 to P2. So what is P1 to P2? P1 to P2 is the linear displacement. This is the linear displacement. So P1 to P2, the body moves P1 to P2. Okay, na? So therefore linear displacement is x. Okay, the linear displacement is x. So from this diagram, according to maths, so this is nothing but arc now, arc length. I am writing arc length. How to calculate arc length? Arc length is equal to nothing but radius into angle. So this arc length is equal to x, radius into radius is r. So this is the angle is theta. So this is the relation between linear displacement and angular displacement. Linear displacement and angular displacement. Or suppose the displacement is very small, then that is dx is equal to, I am writing r into dt. Dx is equal to r into dt. This is the relation between linear displacement and angular displacement. Linear displacement and angular displacement. Here this is important one. This is the relation between linear displacement and angular displacement. So now go with what is our so what is our question here? What is our question? Angular velocity. We want angular velocity. Okay, we want angular velocity. So therefore we want angular velocity, that is omega. So here dx is equal to r into dt. So what is the linear velocity formula? So linear velocity is equal to displacement by time. Displacement by time. So that is linear velocity. What is linear velocity? What is linear velocity, Nana? So linear velocity is equal to v is equal to dx by dt. Okay. What is angular velocity? Angular velocity is equal to omega is equal to d theta by dt. Omega is equal to d theta by dt. Okay, now here v is equal to x by dt, angular velocity is equal to omega is equal to d theta by dt. So now this is the relation between angular displacement and linear displacement and angular displacement here. So now this is the linear displacement. So v is equal to dx by dt, and so what is dx value here? Dx is equal to r into d theta. I am writing r into d theta by dt. R into d theta by dt. And already we are writing what is omega? Omega is equal to d theta by dt. So now omega is equal to r into d theta by dt is equal to omega. So v is equal to r omega. So v is equal to r omega and dx is equal to r into d theta. This is the displacement, linear displacement and angular displacement. This is linear displacement and angular displacement. This is linear velocity and angular velocity. This is the relation between linear velocity and angular velocity. Okay. So now we go with centripetal acceleration. Centripetal acceleration. Okay. So what is our relation? So angular velocity here. Angular velocity is equal to what we get here? Angular velocity omega is equal. Angular velocity omega, and we are getting v is equal to r omega. This is the relation between linear and angular velocity, and displacement dx is equal to r into d theta. This is the displacement and angular displacement. Displacement and angular displacement. Okay. So now we go with the centripetal acceleration. Centripetal acceleration. What is the formula of centripetal acceleration? Centripetal acceleration is equal to a is equal to, we are writing v square by r. Okay, a is equal to, we are writing v square by r. So what is V here? So V is equal to what, Nana? V is equal to R omega. Therefore, R square omega square divided by R, and R gets cancelled. So therefore, acceleration is equal, centripetal acceleration is equal to R omega square. R into omega square. This is the relation between centripetal acceleration. Okay, centripetal acceleration. A is equal. So these formulas are important. V is equal to R omega, A is equal to R omega square, and Ax is equal to R into dt. So these formulas are very, very important. And so one more thing, time period. Time period. What is meant by time period here? Time period means time taken by the particle to complete one cycle. One cycle means here one revolution. Time taken by the particle to complete one cycle or one revolution. That is called time period. Here the time period of the object. Time period. Okay. So remember this formula here. What is time period? Time taken by the particle to complete one cycle. This is one cycle. One cycle means that is total distance, total angular distance. That is nothing but 2 pi r. That is 2 pi. Okay, total time is 2 pi r. So time taken by the particle to complete one cycle. One cycle is nothing but 2 pi. 2 pi radians, 360 degrees. 2 pi radians, 2 degrees. So it is denoted by T number. T. So T is equal to complete one cycle. To complete one cycle. One cycle of displacement. What is the total distance of one cycle? That is 2 pi. We are writing 2 pi now. So 2 pi. So here the time taken by the object to complete one cycle, that is called time period. Okay. So and we go with another important formula, that is frequency. Now frequency here, time period, frequency, both are important. So in circular motion, so what is time period? Time taken by the particle to complete one cycle. And what is frequency? We are using another term. The term is frequency. This term is time period. Time period means time taken by the particle to complete one cycle. So what is frequency? Frequency means number of cycles. Number of cycles to complete one cycle. Number of cycles completes 1 second. It completes 1 second. How many cycles completed in 1 second? That is called frequency. Okay, it is called frequency. So how to write frequency? Frequency is equal to, we are writing n. N is equal to, so number of cycles to complete 1 cycle. It is nothing but it is reverse of time period. It is reverse of time period. Time period means time taken by the particle to complete one cycle. And here, how many cycles complete in 1 second? Complete in 1 second. That is called frequency. So this is the relation of frequency and time period. It is completely reverse of time period. So that's why we are writing n is equal to 1 by t. So remember this formulas here. And how to write omega? What is omega? Omega is equal to angular velocity. So angular velocity is equal to, we are writing 2 pi by t now. 2 pi by t. So angular velocity is equal to, what is angular velocity? Angular velocity is equal to displacement, angular displacement by time. So angular displacement by time period means angular displacement is 2 pi, 360 degrees, 360 by 2 pi. 360 by t, b is the time period. So omega is equal to 2 pi by t is the important. And by using here omega is equal to 2 pi into n also. What is 1 by t? 1 by t is nothing but n. 1 by t is 2 pi into frequency. It is nothing but 2 pi into frequency. Okay. So remember this formulas also. Okay, this is time period. This is frequency. This is the relation of time period and frequency. Remember what is time period? Time taken by the particle to complete one cycle or one revolution. What is the time? So that is called time period. It is denoted by capital T. Frequency, number of cycles to complete in 1 second. To complete, so 1 second. So that is called frequency. It is reverse of time period. Correct? How many cycles completed in 1 second? Number of cycles completed in 1 second. That is called frequency. Okay. These are the important formulas. So remember, these are the very important formulas. And we go with one very small problem. It is based on these relations. Okay. An insect trapped in a circular group of radius 12 centimeter moves along the groove steadily and completes 7 revolutions in 100 seconds. This is the information. An insect trap and a circular groove of radius. What is the radius? 12 centimeter radius. Along the groove, the steering, it completes 7 revolutions in 1 second. In 100 seconds. 7 revolutions in 1 second. So what is the question? What is the angular speed and linear speed? What is the angular and linear speed? Okay. So after second one is acceleration vector a constant vector? Here the acceleration vector means centripetal acceleration. The centripetal acceleration is a constant vector. That is the question. What is magnitude? What is magnitude? So what is magnitude means what is the centripetal acceleration magnitude? What is the centripetal acceleration magnitude? Okay. So here, so first of all go with what is the angular and linear speed. So what is the formula of angular speed? Angular speed is equal, very simple formula. Angular speed means angular velocity here, angular velocity and angular speed. So that is angular speed is equal to omega is equal to 2 pi by t. We are using 2 pi by t here. Okay, 2 pi by t here. So what is 2 pi? 2 pi into 2 into 3 point, I am writing 2 pi. Time is how much? Time is equal to 100 seconds. 100 seconds. So 2 pi by 100 seconds, that is nothing but pi by 50. Pi by 50. So pi by 50 value take directly 0.44 radians. per second. Radians per second. Okay, this is angular speed. What is linear speed? Linear speed. Linear speed is equal to V is equal to R omega formula. This is the relation between angular and linear speed. So V is equal to R omega. So what is R value? R is 12 centimeters. Okay, R is equal to 12 centimeter. 12 into omega. What is the omega value here? That is pi by 50 or 0.44. 0.44. So that is the value directly 5.3. 5.3 centimeter per second. Here I am not centimeter. I am not converts centimeter into meters. Centimeter into meters convert cheyali alane unchukuntam. Okay, so V is equal to 5.3 centimeter per second value. Okay, so now what is our second question? Is acceleration vector is a vector quantity? Is acceleration vector a constant vector? What is its magnitude? What is its magnitude? So first of all we find the magnitude number. Magnitude. After we discuss about what is the vector is constant vector or not. Okay. So first of all, that is A is equal to formula omega square into R. A is equal to R omega square and omega square into R. So this is the acceleration. This is nothing but centripetal acceleration. Why? Because so velocity changes and acceleration is towards the center. Acceleration towards center. Acceleration towards center. Acceleration towards center. Which means the vector is not constant here. The vector direction of vector is not constant now. Vector changes. The direction of acceleration is acceleration. Magnitude is constant. Velocity magnitude is constant, but direction changes. Direction changes continuously. Vector direction changes. So therefore, acceleration is equal to A is equal to what is omega square value? 0.44. So 0.44 into 0.44 into whole square into radius. What is the value of radius? 12 centimeters. 12. Therefore, the value is equal directly 2.3 centimeter per second square. Okay, 2.3 centimeter per second square. So now here actual question is the acceleration. This acceleration it is nothing but centripetal acceleration. Is a vector. The vector is constant vector. He is asking this is constant vector. Is this is a constant vector or not? He is asking that is constant vector or not. Here the direction, whatever the direction of velocity, the direction of velocity along the tangent of the circle. And what is acceleration? Acceleration is equal to change in velocity by time. So change in velocity is there here. Acceleration is equal to change in velocity by time. That is nothing but the change in velocity. So change in velocity is constant, but direction is changes. Direction is the changes. And what about acceleration? Acceleration also changes because velocity direction changes. Velocity direction changes. Velocity direction here. Velocity direction here. Velocity direction here. So velocity direction here. So velocity direction is changes continuously. Okay, na? In a circular motion. And acceleration also changes. Why? Because the acceleration direction of acceleration here. Direction of acceleration. Here the direction of acceleration. This is the direction of acceleration. This is the direction of acceleration. So therefore, the acceleration vector is not a constant vector. It is not a constant vector. It is continuously changing. So therefore, what is the question? Is the acceleration I'm writing the question once again because of clarification only. What is the question? Is the acceleration vector a constant vector? Constant vector. Okay, so this is the magnitude number. And is the acceleration vector is constant vector? No. Why? Because the acceleration is towards center of circle, toward the center of circle and the direction. And the direction, what about the direction? Direction changes continuously. Okay, continuously. Continuously. Okay, na? Clear? Why here? Because the velocity changes. The change in velocity direction changes. So therefore acceleration velocity, acceleration direction also changes continuously. That's why it is not a constant vector. It is change in a vector, direction changes. It is not a constant vector. The acceleration towards center is the circle. That's why the direction changes continuously. Direction are the continuous change. Okay. So therefore the total complete motion in a plane chapter is completed.